How can you wrap your head around the true scale of the universe? Will humanity ever colonize gas giant moons? Can ISS missions compare to future Mars missions? And in Q&A Plus, did James Webb produce any good science papers? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Chiroptal. Fraser, I've heard you mention that you see humanity inhabiting the entirety of the solar system. Do you see us colonizing gas and ice giant moons or more interplanetary space stations? Yeah, like people always think that I'm like Mr. Buzzkill about human space exploration. And, clearly someone was listening, which is that while I may feel that our short-term space exploration plans are going to be less adventurous and less exciting than science fiction had led us to believe, long-term, we're going to completely dominate this solar system. It feels kind of inevitable. And that inevitability just comes from our sort of continual growth of our economy. You can look at the growth of the economy for thousands of years, and it is this exponential growth that just keeps going. And now we are growing at, say, 2% per year, and you chart that forward hundreds of years, and that's more than planet Earth can support, which means like either we go extinct, we flatline our growth, or we go to space. And I prefer space. And you just keep going. And within a couple of hundred years, we are using a large amount of all of the materials in the solar system. Now, what exact form that's going to take, we don't know. Hopefully we'll have the wisdom to do that in a way that is, ethical. But, look at how we treat planet Earth, right? Like we just sort of move into a space and we just take over. And we just keep taking over and getting bigger and bigger. And, that will probably do to space too. So like what exact form is that going to take? We don't know. The inner solar system, Mercury, Venus, Earth, Mars, the asteroids, they have the metal, the rock. The outer solar system, the moons of Jupiter, the comets, the Trojans, they have the ice and all of the volatiles. And all of these are required for us to be able to continue on in our economic growth. And so like what exact form will that take? I always say that gravity wells are for suckers. And so my preference is that we don't go back down into gravity wells, that we do build those giant space stations, those O'Neill cylinders. I think that's a sort of cooler idea. Then we can kind of leave the planets and have them be wildernesses that we can go down and visit. There are a lot of health concerns about trying to live long-term on a place like Mars or even the moon. We don't know what lower gravity is going to do to the human body over long periods of time. One possibility is it's fine. We can go down to 1/3 gravity on Mars, 1/6 gravity on the moon, and that's enough gravity for the human body to function properly for an entire human lifetime. But another possibility is that it's not, that you can't gestate babies. You can't grow them to term. You can't have your bones form properly in that lower gravity. That anybody who tries to live on Mars for any long period of time is going to experience tremendous health effects. And so instead, you go to space where you just rotate your space station and you get to dial in the exact gravity that you want. So who knows what form it's going to take. But I think seeing the rise of technology, it seems amazing. It seems like it's just going faster and faster and faster. And when you take sort of a exponential perspective on the growth and the speed of how things are growing, then things make more sense. They're still baffling, but they make a little more sense. And so you can kind of take that idea of exponential thinking and think about the future of human society and get some glimpses of the directions that you think humanity is going to go in. But the specifics are a mystery. Nick Stokes, what is one of your favorite ways of imagining or contemplating the scale in the universe? It's really difficult to wrap your mind around the universe. And part of that problem is that we know that when we're looking out into space, we're looking back in time. that we are seeing the moon as it looked, a second ago. When we look at the sun, it's 8 minutes ago. When we're looking at Andromeda, it's 2.5 million years ago. And when you're looking at the cosmic microwave background radiation, it is 13.8 billion years ago. And so it's not what's there now, and it's not even where there is now, that we're seeing the light that was given off back then, but now that stuff has moved farther away. So for example, the light that left the cosmic microwave background radiation was 13.8 billion years, but now that actual location of that place that gave off that light is about 46.5 billion light years away. What we see is how the universe looked when it was 380,000 years after the Big Bang. But those places have continued to evolve in the same way that we have here in the Milky Way, that what looks like just this diffuse red glow shortly after the universe has evolved into probably a galaxy that is, the same age and maturity as we are. And it is 46.5 billion light years away from us. And so it's really hard to kind of contemplate the size of the universe and not have your brain switch into one of those modes, right? Because like all of the pictures that we see, when we look at pictures taken by James Webb, we are seeing galaxies as they looked 800 million years after the Big Bang, 500 million years after the Big Bang. We're not seeing them as they look today. When we see pictures from the Hubble Space Telescope, we're seeing the Sombrero Galaxy. Okay, now we're tens of millions of light years away, so tens of millions of years ago. It's kind of the same. But the farther away you look, then the more this stuff is now a snapshot of the past. And when we think about the universe, the observable universe, it is sort of like it's a universe of time, because the universe has had 13.8 billion years to send these photons to your eyeballs. And it's not how the universe truly looks. So you sort of, for me anyway, I don't know how it works for you, but my mind just kind of flips back and forth. I think about the universe sequentially in time, and then I think about the universe as it must look today. And I can't hold those two thoughts in my brain at the same time. But both cause wonder, right? Both cause amazement in my mind. Probably more so that we're looking back in time. I can sort of imagine a galaxy like the Milky Way, but just think about events unfolding that we are looking at, and we're seeing slices of the cosmos back in time. That blows my mind. And I have trouble holding it together in my head without just kind of going, whoa. So, you ask, what's my favorite way? Like, I don't even know if it's possible to not just have your brain break when you try to think about this kind of thing. It's time to shout out all the new $5 patrons and above. Don Carr, Eric Runquist, Harry Hodge, Tom Clark, Garrett Carver, Jonathan Poe, Rhythm Chameleon, Josh Brandt, Mari, and Bryce. Join the club at patreon.com/universe today. Santiago T75. Fraser, isn't it a bit disappointing to know that our eyes would not really see space the way we see those beautiful pictures if we were out there? Yeah. Like whenever you watch a science fiction television show, think about Star Trek or the Orville or really any science fiction show, they're going to show pictures of nebulae around the spacecraft. And the reality is that that's not what you would see. That even if you were right next to a giant nebula, the Orion Nebula or something like that, you wouldn't see the colors and all of that. That the only way you could see that would be with a long exposure. Our eyeballs just can't store enough photons to be able to give that view. And also, as you get closer to one of these objects, they fill up more and more of your field of view. And so the kind of the average amount of light that's coming from it is averaged out across that entire size. And like a good example is that we are embedded within the Milky Way, that we could not be closer to the Milky Way, right? That we're in it. And it is this giant band of stars. That is thousands of light years wide, that we are embedded within. And we are staring from the disk of the Milky Way towards the center of the Milky Way. And yet, if you go outside even in the purest, darkest skies, what do you see? You know, it kind of looks like a cloud, right? You can sort of tell. You wouldn't see this beautiful, grand spiral galaxy sweeping out in front of you. Andromeda is huge in the sky. It is about 9 times as big as the full moon. Think about the size of the full moon. Andromeda is like, imagine a square that is 9 times the size of the full moon. It's right there in the sky. And you don't know where to find it. Like I know where to find Andromeda because I've looked at it with a telescope. I can go outside and I can spot its location and I can point it out to someone. I was like, you know, in perfectly dark skies, we're like, oh, look at that fuzzy bit over there. That's Andromeda. Like, no, yeah, that's it right there. And then you look through binoculars and you see like a bigger fuzzy bit. You look through a nice telescope and you see an even better fuzzy bit. But it's only when you start taking a picture, when the photons can collect over minutes or hours, do those beautiful nebulae pictures actually start to come together. And so science fiction has told you a lie. You would not see that. And so you don't need to wish you could go and fly your spacecraft out to the edge of the Orion Nebula so you could stare out into the vast, beautiful purple clouds of the Orion Nebula. It would be disappointing. Only when you took your camera out and started capturing long exposure pictures would you see something that would make you really impressed. And it would look very impressive once you had the camera going. It is heartbreaking to tell that terrible truth. The film are 6-month missions on the ISS simulations of Mars missions. Not exactly. The missions to the International Space Station are science missions to better understand how to live and work in weightlessness, in the low Earth orbit environment. Going to Mars brings on a whole bunch of additional challenges and additional risks and so on. But there is really valuable things that are being learned about the International Space Station. When you think about some of the technologies that are being done on the station, you've got launching from the Earth in a rocket, docking to spacecraft in orbit, moving around in weightlessness, putting on spacesuits, going out and working on your spacecraft, reclaiming oxygen and water, handling waste, being able to do science experiments when you're in a difficult environment, being trapped in a tin can with a bunch of other people who may get on your nerves, dealing with the issues of having a medical emergency, which is the thing we learned about this week. So those are all generally applicable to spaceflight. And once you go to other places, let's say you want to go to the moon, then there are additional challenges that you have to layer on top of that. You have 1/6 gravity on the moon, so that you're no longer weightless, but what are the challenges of trying to live and work and walk around in that 1/6 gravity? When you look at the videos of the astronauts on the moon, they were falling around. It was pretty hilarious, tripping. They were having a hard time walking and eating, drinking. Like, it's all going to get weird when you're in that 1/6 gravity. You're no longer protected by the Earth's magnetosphere when you're on the moon. And so you have to have better protection from radiation. You're 3 days away. And so if you want to come home, if you have an emergency and you've got to come home, you're still looking at minimum 3 days to a week to be able to go from the moon back to Earth before you can splash down. The speeds that you are re-entering the Earth's atmosphere when you come back from the moon are much higher because you're falling into this gravity well from farther up. On the moon, you have the long day-night cycle where you've got 14 days sun, 14 days darkness. You have to sort of manage that time period. Once you go to Mars, then there are all kinds of additional challenges. So now you've got the 6 to 9 month journey to Mars where you're in weightless, so you don't get that gravity, and you're also experiencing that full radiation of being in space. You have to definitely deal with reclaiming your oxygen and your water. You're dealing with being able to generate your energy while you're getting farther and farther away from the sun. So there's all kinds of challenges. If there's a medical emergency, that's just too bad. You are on your own, right? Because you are on a trajectory that's got to take you past Mars first before you can come home. Once you get to Mars, then you've got to do the descent and landing onto the surface of Mars. Now you're dealing with 1/3 gravity, which maybe is easier to work with, but still, you're still exposed to pretty much the same amount of radiation on the surface of Mars. Now you've got, and I didn't even mention the regolith on the moon. You've also got the regolith on Mars that is getting into everything, covering your solar panels. It's got to be cleaned up on a regular basis. You've got the toxic perchlorates in the regolith that you have to deal with. There are a lot of challenges. All of the food, you need to have brought all of the food and all of the water and all of the air, although you can make some of that stuff locally on Mars once you get there, but you're going to have brought all that stuff with you, and you have to be able to manage it while you're on the surface of Mars. So that is a lot of the challenges. So I don't think, like NASA doesn't see the International Space Station as this direct analog to Mars where they're training people to live on Mars. It's just that there are lots and lots of skills that we will learn about being in space that will be applicable to when we go to the moon and when we go to Mars. But there are these Mars analogs. So several countries, the US and China, do analogs where they put researchers, volunteers, into a simulated Mars environment. Now, obviously, you're still going to have Earth gravity. Obviously, you're still going to have the oxygen of the Earth. It's very easy to deliver food and water to you, but they try to simulate the experience of being on Mars. They have to put on their spacesuit when they want to leave their base. They have a communications delay, depending on the distance from Earth to Mars. It can be up to like 20 minutes. For a one-way communication to Mars. And so they simulate all of that and try to see what are the breaking points, what technology fails, what challenges do the simulated astronauts encounter as they're trying to go about their business on simulated Mars. And it's a great idea. And then the Chinese have a project called the Lunar Palace. It's kind of like Biosphere 2, where they can seal a bunch of people up in an environment and then test to see how their oxygen lasts, how their food lasts, and so on. And can they grow plants and get by and in a fully cyclic environment. So there is some work being done, but not as much as I would like. Like it would be great if the Biosphere 2, for example, and I always bring this up, which is, Biosphere 2 was this amazing experiment in Arizona where they built this self-contained habitat where it was sealed off from the environment, and then a bunch of people would go and live inside of it, and they'd grow their own food, and they'd breathe their air, and they'd have animals, and that we would find out whether or not it's even possible to, do we know enough to run an environment? And, in the end, there was a problem with the concrete and it was sucking oxygen out of the atmosphere as it cured. And so the bionauts, I forget what they were called, were running out of oxygen. And so they had to give them more air and they covered it up. They didn't tell people what was going on. And it was kind of humiliating. They shut down the whole experiment. And now it's kind of an embarrassment. But the facility is still there. I've been to it and checked it out. It is awesome. And they're still running science experiments in the Biosphere 2. But I think, if we're going to want some kind of long-term presence on the moon or Mars, we need more of these kinds of experiments. So we need to do proper closed loop environments where we really dial in being able, and ideally we do this in space. A closed loop environment in space where we are not having to send water and oxygen and food to the astronauts on board the station, that they are growing everything and they understand what it takes to be able to live in this closed loop environment. That's what it's going to take. And very little of that work is being done. Lots of people are talking about the big rockets that they want to send to Mars. Very little energy is being spent talking about all of the vast array of technologies that are going to be required to keep people alive on Mars when they get there. And that should tell you that the plans aren't very serious yet, or that people are just going to die by the droves, right? You take 100 people to Mars and you open up the door and you just let them go outside. And then within a couple of hours, they're all dead. So no, you've got to be serious about keeping everybody alive on Mars. And so you'll know that we're in that direction when you see really impressive closed loop environments developed and run for years on end on the surface of the Earth, in low Earth orbit, and on the moon. That's what it's going to take before we know that we're ready to go live on Mars. And not just YOLO. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, did James Webb produce any good science papers? I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. We were off last week until there was a delay, but we're going to be back until the next live show will be Monday at 5 p.m. Pacific time. Now, I'm going to sort of tackle a question that was asked about how we structured the interviews. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Karen Wentz, Chuck Hawkins, Commander Bailock, Dark Finger, David Gilton, David Matz, Evan.pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepReynolds.org. Please follow my nephew, VBrick694, Ray Kaidu, Richard Williams, Sean Sargent, Team Family Monthly, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this comment from Music Cassette. The topic is very interesting, but the way the interview turned out was a bit hard to follow. I think we need a structured summary. So with the interviews, I am sort of giving you, the audience, a peek behind the scenes of what it's like to watch a journalist do their work. That up until a couple of years ago, I still conducted all of these interviews. I just never made that process public. I would reach out to a researcher. I would ask them a bunch of questions about their work, and then I would use that to inform videos that I was working on or stories that we're working on for Universe Today. And we still do that, right? I am still, in many cases, breaking news by doing these interviews, talking to people. I then pass along this information to the writers who are working on some of these stories. But I'm also live streaming or recording these interviews, and then you get to watch them. And in many cases, we're just kind of following my curiosity about the subject. And I don't really know where the story is going to go. I don't know what the plan is beyond, I have parts of my knowledge that I know are incomplete, and I'm trying to fill those pieces, gaps in my knowledge. And it's a very instinctive process. Right? That I sort of identify the terrain, where are the gaps in my knowledge, ask the expert those questions, and get the answers in their words. But it would be interesting to me to know how these interviews could be more useful to you as an audience. In this case, Music Cassette was saying, well, could we have some sort of a structured summary? Obviously these are the kinds of things that we can generate. And sometimes AI bots will drop into the comments and provide a structured summary already. But I'm like, would that be useful? Some kind of summary of what was discussed? Follow on resources? Like, my hope is that you will, like me, have this curiosity about some subject. You will trust that I will ask the kinds of questions that will give you more information, and you'll walk away with a better understanding of that subject matter. You're not then going to be assigning stories to your writers in the way that I will, but the hope is that you'll be able to follow along better. So I would just love to know, what could we do that would make the interviews more valuable to you as an audience, while still fulfilling its primary purpose of allowing us to do journalism for Universe Today. So let me know. All right. We'll see you next time.